All right, we're given this reaction. We initially have this many moles of N2O4 placed in a 1 liter container, allowed to reach equilibrium. At equilibrium, the final concentration of N2O4 is 0.3. Calculate the equilibrium constant for this reaction. Remember that the equilibrium constant is basically the concentration of your products over the concentration of the reactants. And you just have to make sure that you're raising it to the correct power based on the ratios, right? The coefficients, right? So in this case, right, because we have a 2 right in front of this NO2, the equilibrium constant is going to be the concentration of NO2 to the second power because it's 2 moles. And this is going to be divided by the concentration of your reactants. So the concentration of the reactants, well, N2O4 is our reactant, and it's raised to the first power because the coefficient is 1. Now, we are going, in order to do this problem, in order to calculate the equilibrium constant for this reaction, we are going to set up an ICE table. I stands for initial concentration, C stands for change in concentration, E stands for our equilibrium concentration. Remember that we were trying to find the equilibrium constant, right? So we need the concentrations of both our products and our reactants at equilibrium. So we're essentially trying to find this E right over here, the equilibrium concentration. All right, let's get started. So initially, we know that we have 0.500 moles of N2O4, and 0.500 moles divided by 1 liter gives us 0.500 molar. Because remember, it's concentration, right? So we have to measure this in molarity. And we know that at equilibrium, there's 0.0300. So that means that our final concentration is 0.300 molar. All right. Now let's take a look at this. So for our other NO2, right? So this is for this side is for N2O4. But if we're talking about NO2 on this side, well, originally we started out with 0. All right, we originally started out with 0 concentration. Well, we're just going to use a variable x. Okay, so let's say if this is N2O4, right? And let's say if it loses a concentration of x, right? Because we started out with reactants, right? The reactants are going to react and turn into products. So we're going to lose some reactants in the process, right? So let's just say this losing the reactants part, let's just call it minus x, right? We lose some reactants, and at equilibrium, our concentration is just going to be 0.500, our initial concentration minus this change in our concentration. All right, so at equilibrium, this is going to be our sort of final concentration. Final concentration for N2O4, right? So the equilibrium concentration is always going to be your initial concentration plus the change in the concentration, right? Because this initial, if you add this change in it, it's going to give you the equilibrium kind of concentration, right? Now for the NO2, well, for every mole of N2O4 that we are losing, well, we're gaining 2 times the amount, right? We're getting 2 moles of NO2, right? So if we lost a concentration of X for N2O4, well, in that case, look at the mole ratios, right? If we lose 1 mole of N2O4, we get 2 times the amount of NO2. So if I lose an X amount of N2O4, I'm going to get a plus 2X amount of moles. 2X amount of kind of concentration, right, for our NO2. So 0 plus 2X gives me a final concentration of 2X. Okay. Now we said how at equilibrium, we said how this 0.500 molar minus X, this represents our concentration for this N2O4 at equilibrium. All right, it's going to be this concentration minus some value. That's going to give me this. However, we're also given that at equilibrium, we have 0.300 moles. So we could just set these two things equal to each other, right? And solve for X. So 0.500 molar minus X is equal to 0.300 molar. And doing the math, you just get that X is equal to 0.200 molar. So now that we know what X is equal to, we can sub in X into our X right over here, right? So 2 times 0.200, that's just going to lead me to 0.400 molar. So now at equilibrium, I know that the concentration of my N2O4 is going to be 0.300 molar, and that my concentration of my products is going to be 0.400 molar. So now that I have these two values, I can plug them in back into my equilibrium constant expression. So this is just going to be NO2, so it's going to be 0.400 molar, and this is going to be to the second power, right? This is going to be divided by the concentration of N2O4, so the N2O4, the concentration of that, we said that was 0.33. I mean 0.300. So then 0.4 to the second power is 0.16. Divide that by 0.3, and you get around 0.53 as your equilibrium constant value. And that's going to be the answer.